chapter 3 or start reading chapter 3. And that's on page 23 of my textbook. And the reason is that it'll give you a little bit of understanding as to why we're going about it, right? So if you have already read it, awesome, that's great. If not, that's also okay too. It's just that if you need a little bit of background information as to what we're doing, why we're doing, obviously we're going to talk about it. It's just that I've taken the time to type it out in my vernacular and my writing so that it sounds so stiff or stuffy in terms of how we're describing it. Okay, so you want to go there because I feel that I take the opportunity to go, hey, this is mathematical modeling. These are the details we've been learning, whether they are algebra, finance, a mix of both, or something new. We're going to learn a little bit something new, but it's not going to be anything terrible. And it will help us integrate into our mathematical modeling and how we pull things all together, right? Obviously, everyone's not an FBM major, but you've come across, whether you are the major, it's in your major core classes, or you have classmates, friends, whatever the case may be. But the thing to keep in mind is that we are shooting for profit loss statement. Okay, and again, that is unique, I believe, correct me if I'm wrong, FBM majors, to the FBM major. And what does that mean? It basically means, oops, FBM, not FMM anymore. What it basically means is that you have some kind of expression, if you will, and most of the time it's something of the nature of income minus, and I'm going to use red here because I rarely use red, but I want you to really have this idea of income minus expenses. And then whatever this profit loss statement is, this is going to translate as our model. Okay. If you're curious, we have 3 lines here. That's just mathematics right there. Representation or mathematical symbol. This mean is defined as. So they're equivalent. Well, not equivalent. They're defined as to one another. When I ask for, hey, find me the model, I'm asking you to make a profit loss statement. If you have a profit loss statement, or if I'm asking you, hey, what are all your incomes and expenses all combined together, I'm asking you to make the model. So no matter how difficult or how vague a question may be, you always are looking for the model at the end of the day. And then what happens is that once you find the model, you can answer follow-up questions. And in my textbook, I take the time to go, hey, these are the pieces of how we're going to, don't worry, we're going to do it all here too. It's just that I'm going to constantly reference my textbook because, well, I'm writing it so that it can be something that can be read alone or something that can be used as a reference or as a supportive tool as you're going through reading or learning, whether you're in this class or whatnot, okay? Let me just make sure that no one's trying to get into the class right now. The reason I started the waiting room, I know it didn't kick in automatically, but for those that were joining in, is that I've been introduced to the phenomenon of Zoom bombing, and it was pretty bad. And Columbia already had a moment where someone was doing, or at least the Columbia Teachers College mathematics department already had some kind of small lecture going on, and then everyone was blasting on Facebook saying, "Oh, super disturbing." They didn't say what the heck it was, but whatever the case may be. Okay, so yeah, from here on forward, you probably saw in the announcement sections too, as I was editing it, I'm keeping a waiting room so that I have to allow people to enter so that we don't get bombed or whatnot. But I'm not gonna go as far as making a password because that's kind of annoying. Okay, so this is what you wanted to keep in mind. Also, the other thing you want to keep in mind is that we always go through the same steps more or less. So when approaching any of these problems, right? When approaching any of these problems, they are always. Now, always is, of course, a strong word. It's in terms of our class, at least. If for whatever reason, some way, somehow you find yourself in a modeling class having to do with mathematics in the future, of course, I'd be quite proud of that. But as far as this class is concerned, they are always in 3 steps. And these are the 3 steps right here, 3 steps. So one is, there will be, you want to either find or solve the components or pieces that make up the model. Make up the model. Okay, so components or pieces that make up the model. So if you ever played with Legos, for example, or even looked at them, you'll find out that Legos, you don't start from the base of any model or toy or whatever the case may be, and then you build it up. You sometimes work on little pieces here and there, and then once you get to that final step, you can start combining them all together. But they'll have you work on little pieces at a time. So those will be like section A, section B, section C, D, and so on and so forth. And then what will happen is that at the end, they'll say, okay, combine these sections together in this way. Which leads to our second step here, is that once you have all the pieces, use the components to build, or in our case, or write the model. Okay. Another thing to keep in mind here is that when people get to this part right here, they think that they're solving for something, and that is only half true, in the sense that you find the pieces and the components that you've taken the opportunity to solve or calculate or whatever the case may be. And then once you get to the model, what you're doing is you're just creating an expression, right? Your work that involves the model does not involve solving for anything just yet, right? In other words, these 2 steps right here are equivalent. In other words, when we find or build or write the model, that means write out your income minus expenses, or your profit loss statement, right? So here I'll note as well is that note you are not solving for a single solution. Actually, you know what? Sorry, no, I'll write this better. Get rid of single, a finite or numerical solution, right? So it's not a number, in other words. Your model is never, for this class is concerned, a single number. However, once you find the model, you will have follow-up questions. Follow-up questions can be single answers or single numbers, if you will. Answer follow-up questions. Involving model. Okay. Those are our 3 steps. That's how it's always going to be. I can already tell you right now that parts 1 and 3 right here, 1 and 3, will have multiple steps. Obviously, it's not going to be a bajillion or even 10 or anything of that nature because it's too much work. It becomes very lengthy. There is an example in the textbook that talks about, oh, what would it look like if you had a very super comprehensive example, whatnot. However, homework as well as what will lead up until the final, they're not going to be long because it just takes too long, right? Even if I gave you guys a longer extended period of time to do the problems, these parts in green right here, they'll have multiple parts. And of course, we'll start with a simple one first, and then we'll work our way up. Okay. Let me just go back to see if there's, I'm trying to still get into class right now. And then we got questions here. Okay, never mind. And then Young is, all right, good. All right. All right, so let's start with a simple example right now. So here's example 1. Suppose we have finances coming up for, let's jump a month ahead in May, right? We have finances approaching for May, for the month of May. Right, and then we're going to say something such as, we have a goal, $250,000 to meet by putting money away each month. Okay, you make $30 an hour. And you have a one-time deposit of $500 to make. Okay, so as you write this down, or whether you're writing it down or following along, whatever the case may be, right? Notice that not all the pieces are there to make a proper question. However, this is just a very baby step question in terms of approaching what's going on, right? So then normally you'll have a question that I write that says something like this. So normally I call it the leading question, if you will. And it will always more or less be of this statement. How would you represent the above situation for May? And what that translates to you is basically, make me a model. Okay. Now, as you know already, our model is going to be the same exact thing as things that make you money, less or minus things that cost you money. Normally, when you see something like this, you just want to break it down piece by piece. So if you're looking back at example 1 right here, I'm going to start right here with the we right here. So obviously, this is just talking about the story or the word problem itself. Okay, we have a goal of $250,000 to meet by putting money away each month. So that's one piece right there. So I'm going to put a nice little box around that. Okay, you make $30 an hour. I probably should put the make in the box. And then we have a one-time deposit of $500. So what I want you all to realize, this box moved now? I don't think so. No, it won't. That's fine. What I want you to realize is that there's 3 pieces to this situation, right? You got 1. No, let me use a different color. You have 1 right here, 2 right here, and 3 right here. And of those 3, it will always categorize into one of these 2 categories, if you will, right? You can always place in one of those 2. So hopefully, even though it's been a while, people realize, oh, number 1 goes in the income, right? And then number 2 and number 3 go into expenses, okay? Now again, why is number 2 going into the expenses, even though you'll be making money in the long run of $250,000, is that you don't have that $250,000 now, you have that $250,000 later, and you're gonna be putting away the money each month, okay? The $30 an hour is the only thing that's actually going to make you money, and then you have this one-time deposit of $500, right? So that's basically what's gonna happen there. Now, how do you write it out? Well, it doesn't really matter right now because I didn't give you enough information, but it's just allowing you to see what is starting to go, or what is starting to happen, or how the pieces are identified, or how they start coming together, right? So this is where in this first step still right now of identifying them. And then what will happen is that if you look at number 1 here, or circle 1, I should say, right? $30 an hour, you know, that's something simple. You would say something such as 30x, where x equals hours worked. Okay. And then here on the right side, I'm going to write on the right side, expenses. You're putting away money each month, right? And as you should remember, this is going to be an annuity, because you know you're putting away the money each month. Since you have a goal, it's going to be future. And then if I gave you enough information, you would have been solving for the recurring amount for the future value. What is that amount? In this particular problem, this baby example we're starting off for the day, doesn't matter. It's just a matter of having you accustomed to recognizing it. Okay, so again, there's no finite answer here. There's no numeric answer here, right? Some of you might be going, well, wait, what's the length of time? What's the interest rate? You know, how much are we putting away? What's the goal? You know, whatever the case may be. Again, we're not doing an actual problem just yet. This is just a matter of setup. And then 3, it's the one-time deposit of $500. And you know, that's just $500. So once you put it all together, your model should look something like this, right? Your model, I'm gonna scroll up now. It's going to be this 30x. And then you're gonna subtract off whatever that monthly payment is, as well as 500. And just like that, that would be the expected model for this particular problem, right? So you have things that make you money versus things that cost you money, which is a combination of these two. Now, for those that are really algebraically inclined, sorry, I don't know why I can't do this right now. I'll do it this way. There we go. This subtraction right here of the expenses, you can do it however way that makes you most comfortable, right? You could have even wrote it as 30x minus, and then in parentheses here, the monthly payment plus 500. But they're the same thing, right? Just realize that if you subtract off each component or each expense, that's the same thing as subtracting the total or the sum or the addition of all your expenses together. So either of these are correct, okay? So what happened here? All of this that I wrote here that I was boxing in purple squares, and then I wrote out the model so I can remember or remind you what's going on, and then I wrote down these pieces 1, 2, and 3. That's all step 1, right? That's identifying your components or your pieces, if you will, right? Some involved calculations, some did not, right? And then when we get to the model itself, that's step 2 from up here that I was talking about. From step 2 here, we have our model, and notice that the model will never be a single or a finite answer, right? In other words, it won't be a single number, or it won't be a single digit or multiple digits or whatever you're thinking. And what happens is that that's pretty much it. You leave that and that's it. Now, we don't have any follow-up questions here because I didn't give you enough information, but this is the consensus of how you'd work through. And this is where it really matters as to being able to tell the difference among all the finance equations, because when I start listing them all, you have to be able to identify the correct components with the correct equations that we've learned in the past so that you can build your model correctly, right? So now more than ever, things will really rely on the previous step type of thing, just like in cost revenue profit, how it was very critical that you got the first 3 equations correctly, right? The profit equation, the revenue equation, cost function. And then what happens is that everything followed after. Well, this is a bigger or a larger scale of that, okay? Before I move on, let me just make sure there's not any questions right now. Everyone's still here? Yep. Nobody's in the chat. Okay. All right, we're okay to move on? Okay, so here's example 2. I think what I'll do is that for the rest of the semester, unless I'm having one of those Thursday lectures where it's more answering and asking questions of whoever shows up, I think the Tuesday lectures, what I'll do is I will upload or email. You know what? No, I'm going to email. I'm not going to upload. I'm going to email you all the questions out in advance so that you can write it out in advance if you want, because, well, we're no longer in person, so I can just kind of plan a little bit and look it up in advance, okay? Okay, so this is what we're gonna do now. Suppose you have revenue generated by 5 times number of employees Okay. You have a goal of $1 million over 3 years at 4.25%. Compound monthly with monthly deposits, and lease to your office is $250,000 at 5% over 20 years. So you'll see a problem like this, for example, and then it will always have the same leading question, which is, how would you represent the above monthly situation? And all I'm asking you to do is that once you figure out the pieces of each of these three, you're gonna combine them together, similar to that of a profit loss statement, and then you're gonna give it to me in the form of a model, okay? So that's what's happening here. And then afterward, we'll always have follow-up questions, and I'll write them out right now too. So an example is, what is the outcome model if you have 10,000 employees? Question mark. Okay. Assuming model stays the same for the second month, except now your income is generated by 10 times the number of employees. How does your model change? And then last is, suppose for the third month, no changes occur, but we have an additional one-time expense. Need to make $500,000 be a single deposit at 7% compound quarterly over 40 years. Deposit, how does model differ? Okay, so that's an example problem of more or less a full-fledged model right there. So again, if you're copying this down, I'll give you a moment to do that. If you're not copying this down, again, this is going to be uploaded to YouTube in our 802 section, and then you can write it down later. As I suggested, or it was suggested to me, what I will do is that the longer problems like this, what I'll do is I will just upload them in PDF form or have them typed out really quickly, and then I'll just send it to everyone so that you can have it already. And then what will happen is that if people don't have it, it'll be accessible via their email. However, I won't just jump right into it. I'll outline some of the details so that you don't have to spend the time watching me just type this out and you typing it out too. And I'll make it a little bit quicker as well, okay? So I'll just give it another 30 seconds so that people can take this in. But as you're writing it, what you want to remember is our plan of attack, right? Those 3 steps. So in other words, these 3 bullets on the top right here, you do this first, right? Despite the fact that you see questions 1, 2, and 3 on the bottom right here, which I'm gonna do in a different color now, these, you don't touch these questions at all. Zilch, nada, nothing, until the model is done. So this is step 3 right here. But people, what they do is they gravitate towards these because they think that these numbers written out in number 3 are supposed to help you contribute to finding your pieces or components in the first step outlined here in purple. These are independent of one another. Yeah, they're somewhat related, they're partially related, but not in the immediate sense. So 1 in purple first, then you're gonna make your model in 2, and that's always this question right here. So this is your model, in other words. And then number 3, you start answering those questions about the model itself. Okay. All right, so we'll start right now. So with the bullets first, right? Let's use purple here. Okay, first bullet here. Okay, I'm gonna scroll down now because I have this written out already, but I'll show it to you right there. Okay, 5 times the number of employees, right? So it's simply 5x, where what? Where x equals number of employees. Some of you may ask, oh, do we need to write out this part of number of employees? Yeah, I would do it, because if you're not defining it correctly, then how do I know if this x is for something or for anything else? Or what if you mix it up and you put an x somewhere else where it shouldn't be, and so on and so forth, right? If you're curious as well, the component that we'll be using for the model will be this right here, okay? So again, that's not your final answer, of course, but it's part of our answer, part of our model, right? So this correlates or relates to that first bullet right there, revenue generated by 5 times the number of employees. Done, that's done. And now we can move to the second bullet right here. Now this is an annuity, right? Hopefully you remember that this is a goal for its future value, and then that you're looking for the monthly deposits. How do you know that? Because I already told you that your goal is $1 million, right? You can't solve for the future value if I've already given you the future value. And since the monthly deposits are, well, since the deposits are monthly, you know the compounding period is 12 right here, right? So with monthly deposits means that the compounding period is 12. Okay, now I'm not going to write out everything as we normally would, but I will write it for this first time because this is going to be a good review for the not only the second exam right now, but the final as well, right? So when I said on the second exam, if you recall, to list the variables, when you list them, people did that correctly. People did this mostly correct. So I would say about 98, 96% of you did this correctly with the future value. And then I told you that you're looking for the recurring payment. And this is where I had to go back and give points back, right? The answer here for the interest rate is not 4.25%. That's incorrect, right? Why? We never use the percentage sign in an equation, right? And then some of you wrote, oh, 0.0425. That's still wrong. Why? Because every time we do an annuity, what has to be involved with the interest rate? The compound period. So the answer, I'm not sure if you can see it when you go back to look at your exam, because the answer should be posted now, is 0.0425 over the CP. That's why in the instructions I said write it out as you would if you were to input into the annuity, right? If you're throwing in the annuity, you're not using this method, you're not using this method, you're using this fraction right here. Same with the time, right? It was 30 years. So in this case, I wasn't looking for 30 because when you have the equation written out right here, which I'm gonna write out really quick for everyone, just as a nice little reminder, because we're going to use it, right? You don't put 30 there. You put 30 times the compounding period. And this will prep you for the final. So 30 times CP, or if you happen to write out whatever this number was, which was 360, okay, that would be correct. These are things that go into your model, right? Not this, not this, not 30 by itself, right? So I gave partial credit back. If there were any weird formatting issues, I definitely gave full credit back. But if you're wondering like, hey, why did I get it and I wrote the right answer? It's like, yeah, you got half of the right answer, or partially of the right answer, right? We never use just the interest rate or the years by themselves in our equations, right? So let me write this out really quick for everyone so that they can do it. So it wasn't this equation, we need the other one. So it's actually this one, future value, 1 plus I and minus 1. Either way, whether it's this one or this one, this is the one we're using right now. This is the regular future value right here. Right, but yeah, you just want to make sure you have your formatting correct. So I'm gonna write this out really quick. Scroll up there. One plus 0.0425 minus 1. This is over 360. This is over 12. Okay, so this number right here, which we're going to get, this is our future value. And it is $1,377.73. Okay, so this is the second piece to our model, if you will. Okay, and that was from up here when we were looking at the second bullet. See, first bullet's done, second bullet's now done. We determined by circling here, whatnot, that this was a future value annuity from what I underlined and circled and listed for you here. Now remember, if I lost some of you here, again, you can rewatch this. We're still now in the first component for the model, right? This one step right here, or step 1, right? What's happening right now is that we're finding the pieces or components of each of these 3 bullets so they can make up the model. Once the model is attained, we can now answer questions that are in this circled 3 right here about the model itself, okay? So again, I know it seems a little tedious and a little long, and they are long. That's why you can't have tons of these questions on your final, right? So they are long. They do comprise of things that you've already studied and hopefully mastered at this point. If not, then that's okay, because we still have time to recoup, because this is basically how we're going to review moving forward, okay? On this last one right here, this lease, this last bullet, to your office is $250,000 at 5% over 20 years, right? This lease is to help you, remind you that this is a present value, and the present value is equal to this $250,000. So that means you're solving for the recurring payment for the present value. And since it is a lease, we said that it's okay to assume that the compounding period is 12 here as well. Okay, so this time around, I'm not going to write down all the details like I did for the second bullet because they're the same exact thing except for the present value annuity. It's this time going to be the present value annuity solving for R, whereas the second bullet we did future. I just wanted to go over and take that opportunity to review with you what we were looking for in terms of formatting or the answers for your second exam. Now, if you did it as intended by reading the instructions and whatnot, you don't have to worry about this right now. This just might seem a little redundant, but right now I'm going to go straight into the annuity itself. So the present value here that we're going to be solving for, it's for, again, that lease of $250,000 at 5%. You know, it's compound monthly. You know, it's 1 minus 1 plus 0.05 over 12. And how long is this for? 20 years. So that's negative 240. Which means that this answer now is, I'm going to write this in a different color here, just so that it doesn't look too similar to the previous answer right here. This is equal to 1,649.89 dollars. Okay, so now we have all three pieces, right? First bullet right there, the 5x in the square. The second bullet here, the recurring payment for our future value to hit our goal of $1 million written here. And then now our lease that we just found here in black, or written in black, I'm sorry, of the recurring payment for our $250,000 lease, or quarter million lease. Okay, so now only after these three pieces are done, you can answer this leading question: how would you represent the above monthly situation? Right, basically what that translates to is put them all together. And if you notice in my textbook, when I write this answer, I write it one of two ways, right? I always write it with symbols or symbolically. And then I also write it numerically. You don't have to give me both. You could do one or the other, but most students choose the numerical one, or numerically, because you take the opportunity to solve for all these numbers, so you might as well plug them in. So in this case, this would be 5x minus the recurring payment for the future value minus the recurring payment for the present value, right? Your monthly saving and your monthly lease. If you're doing it with the numbers, it would look like this instead. 5x minus $1,377.73 minus $1,649.89. So either of these are acceptable for the model. And this is step 2 right here, right? These two pieces, why can't I write this? Right, this is step 2 completed. And notice how the models themselves do not have a single answer, right? They're expressions, they're not equations. The reason they're not equations is there is no equal sign present, right? If you recall from your algebra days, an equation such as x equals 5, x plus 4 minus 7 squared, or something like that, that is an equation because of that equal sign right there. You don't have to write this down. These are expressions, right? They're algebraic expressions trying to represent what's happening here. So again, either these are correct. Okay, again, students generally do the second option because they took the time to solve for those numbers, so why not plug the numbers in? Some students like to move a little bit quicker, and that's why they do the symbolic one right there, okay? And then notice how these questions I marked here, 1, 2, and 3, or in other words, the Navy right here, they had nothing to do with contributing to the model just yet. When you build the model, you have your 3 bullets right here that I have all written in purple, and then they allow you to create your profit loss statement, right? Or in this case, your mathematical model, right? Okay, let me see if there's any questions here. No one's still here. Questions so far? All right, good. If anything, just shout out because when I'm on the screen, obviously I can't see the Zoom app, okay? Once we have the model, then we can go into answering these questions right here. I'll switch to Navy right here, right? So number 1, well, number 1, 2, and 3, right? These are the parts where I was talking where you can have multiple parts. The bullets are contributing to your model, whereas these questions are actual questions about the model. And I wrote this in the textbook too, but what you have to realize is that you don't have to memorize what kind of questions I can ask you, and I'll write them down. It's just that you have to be able to recognize them. So if you read this first one, right, or I'll read it out loud as you follow along. What is the outcome of the model if you have 10,000 employees? What that's asking you is that, so now the questions, right? I mean, you know what it's asking. Specifically though, 1 is a calculated or calculating question. Okay, more specifically, it's telling you that X is equal to 10,000. So what do? You plug it in, right? They tell you that X is equal to 10,000, and then now you can utilize your model for that calculation, right? You got 5 times 10,000. Where did 10,000 come from? It was provided to you. And then where are all these numbers I'm writing now in purple and black? They are from the model. 137, I'm gonna drop the dollar sign now. Minus 1649.89. So you take the time to do that. And then what happens is that this expression now equates to, I have this written down here, $49,972.38. So that's the outcome, and this is a positive outcome. Right? By having 10,000 employees in this fictitious model, it tells you that that month of May, you would have a profit of $49,972, 46. I said 46 and I wrote down the wrong number. Let me just double check this now. I don't trust myself. 50,000 minus 1377.73 minus 1649.89. 46,972.38. Yeah, that's good. Okay. It gives you a profit of nearly $47,000 and it's a positive outcome. When we go to number 2 here, there's a couple of things I want you to notate as well. Assuming your model stays the same for the second month, except now your income is generated by 10 times the number of employees, how does your model change? Okay, most students they understand to keep the questions isolated from one another. So I'll write that here too. Note, keep calculated answers for follow-up questions independent from one another. Why is that? The reason is that if you have to worry about that 46,972 that we just solved for, that means that you have to carry that over as extra profit to worry about. Now, is it true that if you make, this is your business and you made $46,000, almost $47,000, that it goes away? Of course it doesn't go away. It's your profit, it's your earnings, it's what you have. However, for all intents and purposes for this class, right, you keep that there. It doesn't mean you ignore it. It just means that you keep that month's calculations isolated from one another. And at the very end, if necessary, you can total everything up and see what the calculating or running total is, right? So in other words, this 46,000, you should not carry it over, right? Any changes to the model you do carry over, but the calculations themselves, you don't want to carry it over. So number two, again, if you remember, it was right here. It says everything stays the same except the number that's generating your revenue is no longer 5 now, it's 10. What happens for this hypothetical second month, right? For the second month right here, second month's model, I always like to say what stays the same and what doesn't. Well, you still have your expenses, right? So if you're looking at the original model, which is right here, right? Here's the original. You ask yourself, do I have still a monthly expense to put away to hit my goal of $1 million? And the answer is yes. Do I still have a lease to maintain? And the answer is yes. But now all of a sudden, this 5 is what has changed. It changes to what? It changes to 10x now. And all you have to do is just rewrite that representative here for the second month. So here it would be 10x now. And then your expenses stay the same. Hopefully people can see now that this is the exact reason why we avoid bringing that profit right here, this 49,000 or 46,000. We avoid bringing that into the model or incorporating into the model because I want you to have an original model that you took the time to find, which is this one right here that I was writing the check marks next to, so that when you go into or you transition from one month to another, what happens is that you have a base or template and then you just adjust it as necessary, right? Introducing these carryover amounts, whether they're profits or losses or whatever the case may be, only complicates things further. You're not, again, ignoring them. It's just that you're saying, hey, I have it calculated, I have it in mind. I'm just keeping the months isolated from one another, okay? So this is what we're looking for. This is the second month's model right here. The only thing that's changed is that your X has now doubled, right? It has grown by a factor of now 10 instead of 5. So that means that what happens, your model increases in revenue capabilities. Now you don't have to write anything down. You could have simply rewrote the model and call it a day. Sometimes students like to write things down instead of just rewriting a model. So I allow for either answer, right? Whether you wrote out the model right here in the orange box, or rectangle in this case, or you wrote it out in words right here, either is acceptable, okay? For the third step here, or the third question, actually wait, let me label this too. This type of model, this is what I would call manipulative or manipulation question. Manipulating. Okay, and why is it a manipulative one? Right, we're physically changing our base model to something else. Manipulating question. Okay, good. That's what I want to say. Okay, number 3. Let's go back and see what that says. So it says, suppose for the third month, no changes occur, but we have an additional one-time expense, right? So now I'm telling you, hey, there's something different going on now. And what is it? You need to make $500,000. So you can see we have a goal again right there. What's the difference though? There's a single deposit. So the moment you read something like this, right? You know, this is one time, it means immediately not an annuity, right? Not an annuity. So if you have your formula sheet out in front of you, you should realize that this is now not an annuity for this piece right here. So what does that leave us with? Well, let's continue reading. It's a single deposit at 7% compounded quarterly over 40 years. What allows us to do compound quarterly? Well, that's the regular compound period, right? So the third question now, this is technically also another manipulating question as well. We know that there is a goal, that it is one time, and that the CP is quarterly. So that implies we're going to use this equation right here. P equals F 1 plus I raised to the N. Okay? Which means that $500,000, yeah. Which means that we have the following: 500,000 over 1 plus 0.07. Where did that 7% came from? It's given to you in the problem. We're compound quarterly now, right? And we're doing this over 40 years, but it has to be 40 times 4. Just 160. Remember, this is all in the exponent, and then this is going to give you your piece right here. This calculation I don't have, so I need to do it right now for you all. So 500,000 divided by 1 plus 0.07 divided by 4 raised to the 160. So this is going to be equal to $31,150.37. So this is what we need, but how does that fit in our model? Our third month's model now looks like the following. Again, 10x, because we're pulling down from the second month, right? Didn't say anything about reverting back to 5x, so we move on from the second to the third month. We still have our monthly investment. That is still an expense there. We still have our monthly lease. And now all of a sudden we have this additional one-time expense. And this is the answer I would be looking for. All right. And that's it pretty much. In other words, every problem that we're moving forward in terms of review, short of saying, hey, how do we do cost revenue profit? Hey, how do we find the interest accrued or interest earned or whatever the case might be, or any individualistic problem, we will always do those problems because we have them, they're in our notes, they're in our exams, they're a great way to review and all that jazz. Outside of that though, whenever we do a practice problem in terms of preparation for the final, it will be something of this nature, because not only does it practice the model, it also is a nice review of all the pieces that we have learned and that we're going to put together. All right. So I'm going to flip back to Zoom right now to see what questions we have there, if any. How do we feel about this? Everyone's still in the class, right? Didn't lose anybody? Long, boring, stupid, interesting, a little bit more collaborative? Long. So long it took up 3 pages of my notebook. That's funny. Okay, so don't worry. That's what everyone's responses are, right? Oh, it's way too long, right? We're doing way too much. And okay, that's really funny. Okay, so obviously I'm going to streamline this, right? There's 2 things I'm working on right now for not only your section in your class, but also the other section and for future sections too. So remember how on YouTube I said that I will have these lectures recorded where everyone can, I mean, it's kind of awkward to flip back and forth between Zoom because these are actual lectures, but I'll have these recorded and they'll be in playlists respective to your sections. However, what I'm also working on is I'm working on short tidbit videos, and I'm talking no longer than 5 minutes of me being somewhere, whether it's on location, where I just pick something in the city random and I talk about it and I try to pull in a real life consensus from it. I mean, I know this makes sense in terms of real life, yet like we've talked about in class before, no one's running their own business as of right now between both my sections, right? I've had it in the past where I had a student do their own startup business or whatnot, but they're very few and far between, like less than 5. So don't worry about it. Nobody's behind in life, quote unquote. It's just that it's really hard to internalize this when you don't have this many expenses going on your day-to-day basis, right? Most of you have what? Jobs, whether it was under the table, whether you took tips, whether you're doing a short internship, whether it was a long-term job or an internship, and then you would have your expenses, whether they would go directly from your debit card, from your credit card, from rent, from what else? Maybe not a lot of you, but some of you were saying that you're paying insurance or gas, or you're making payments to a vehicle that you're leasing, things like that, which is fine. I'm thinking more large scale right here in terms of the business model or whatnot, but we can scale it down to personal as well. But the point is that I'll be making these videos, these 5 minutes at longest. And what I'll do is that I'll just run down a type of problem like this, and it won't be so long. And then the other thing that I'm going to work on, and this one's going to be a little bit easier, is that whatever lecture that I feel like is going to happen, say next Tuesday, especially if everyone is on par as to what's going on right now, I'm just going to type out maybe 3 to 4 of these questions in advance, and then I'll just go, okay, cool. These are the problems we're going to work on. So then what will happen is that you won't spend half the time just copying it down, okay? All right, let's see what I have as my second. So I promise that the writing will be minimized from today onward, and then what will happen is that we'll move a lot quicker, so it won't feel so long. And trust me, every semester I've taught this, as well as every section of 311 within those semesters, it's the first thing, it's the same thing every time. Very long, it's a little tedious and whatnot. But again, you're all going to smooth it out just fine, okay? So what I'm gonna do now is I'm just gonna copy and paste this right now so that you don't have to worry about writing this out. So this was from last semester. I just wanna make sure I get the correct lecture. Section 802 from last section. Okay. So I'm going to copy this, go back to ours. This is going to be our second example, last example for the day as well. And then whatever we don't finish, we'll just continue on Thursday. Okay. So here it is. If you want as well, for those that are on your computer, because obviously you're on your computer for Zoom and whatnot, what I'm going to do is I'm just going to fix a couple of these things really quick. Leading question. What is the above situation terms of monthly? Nope. Well, just underline. There you go. All right, cool. So if you want, take a moment, give this application a moment to back up. As you can see, that's happening in the lower left-hand corner. And what happens now is that if you refresh the link to lectures under the content section of Blackboard, you'll have that question written out already. So for those that need to, go ahead, feel free to open up Blackboard on whatever web browser you're on. And then what will happen is that when you go to today's lecture, it'll be on the very top. You'll see that, excuse me, you'll see that the question is already written out. So then you don't have to utilize your time to recopy or everything. Or for those that are writing in your notebook still, which is super important, right? Critical to your learning, you can copy it later or at least have it right in front of you and then go from there, okay? So I'll give people a moment. See, normally you wouldn't be able to do this in class because not everyone would have their computer out, or if they did, they'll be doing something else. Or if you're on your phone, for example, sure, you could access Blackboard from your phone, but it won't be super user-friendly, or it won't be, the view won't be mobile-friendly either, okay? So I'll give people about, a good 15 seconds or so, half a minute. Pull up the necessary pages. Remember, this is under the content section of Blackboard. It's today's lecture. It's already been backed up, linked, uploaded to the cloud, and the web page has already been processed. So now when you open it, you should see this written out immediately, and then we can start. Something's low on battery. Oh, it's my left AirPod. Okay, that's fine. Maybe I can charge it for a moment. All right. Okay, let's start now. So here, this example I made up from last semester, right? It says, suppose we sell movie tickets, right? And you can see there's 3 bullets here that are supposed to make up your model. And then you see my leading question there, even though I may have written it in an awkward vernacular here. It's basically, what is the model? And then you can see now there's 4 questions here that are written out in terms of hey, once we find the model, what are we gonna talk about? What are we gonna answer and everything of that nature? Okay, so let's start. Now, if you didn't notice already, you can see that you sell four, this is for the first bullet, by the way. And again, just for anyone that needs it, remember there are 3 parts. So there's this, what we're doing first right now. We're gonna do this a little bit quicker. Then we're gonna find the model. And then we're gonna answer these 3 questions, I'm sorry, these 4 questions? Yeah, 4 questions about the model after, okay? As I was saying, if you read this first bullet right now, you'll notice that it says, hey, you sell 4 tickets for $100 and you sell tickets for $250. Each ticket can be sold for $35. So remember how I was saying that these problems will be a nice extensive, a nice extensive review of what we've been doing throughout class? Well, this is a cost revenue profit portion, right? And this is gonna help you review for when we have those types of questions, whether they are standalone or they are, excuse me, whether they're standalone or they are part of the model. So the first bullet here, and don't worry, I'll scroll back up in a moment. Right, notice that it's a cost, revenue, profit. Cost, revenue, profit. That we haven't done for a while. So remember that's saying this is a single point. And this is another point right here. And we have to find the slope between those two, right? So remember that's M equals 250, 10 minus, and then your next one here is 100 over 4. Okay, so those are 2 points, right? This is the slope. And then now we go, what is this? 250, so that's 150 over 6. And this boils down to what? 25, I think. Yeah. And then from there, you use the point slope formula, y minus y1. As usual, I'm going to pull the smallest point. So that's this here and this here. And 25 goes to where the slope is. So this implies y minus 100 equals 25 times x minus 4. And again, if you use the points 10 and 250, it will give you the same exact answer as long as you didn't make any mistakes, okay? So from here, once you do it and it's all said and done, the cost function, it actually becomes a simple one. This comes out to just 25x, right? Because after you do the algebra, what happens is that there is no y-intercept for that. So this one, I kept it simple because, well, I wanted to. I kept it simple to make it easier, and that was it, okay? The revenue function, how do you get that? Remember, the revenue function is always the piece that is given to you in the model. In this case, it's this sold for $35, right? Right? Each ticket can be sold for $35. So that's this 35x right here. And the profit function is always what? It's always the revenue function. Let me color code that. minus the cost function. So in this case, the profit function will be 10x, right? And this is the piece that's going to be used in our model, right? Some students in the past would have said, well, what about the costs and the revenue function, right? Aren't those part of our expenses and how we do things and everything of that nature? And the answer is yes, they are. They absolutely are. The thing though is that if your profit function already utilizes both those details, then why do we have to put them in again, right? It becomes redundant, if you will. It becomes unnecessary and becomes repeated information that could actually make our model more complicated. So at the end of the day, if you're ever given a cost, revenue, profit, just realize that all you're doing is you're doing the same exact work like we used to, except you're only using the profit function. Okay, so that's the first bullet there. What about the second bullet? Second bullet says that you have a lease to your office, right? Lease to the office, it's $300,000 at 4.26% for 35 years. So it's the same thing as the last problem, right? Leases are present value. I don't have enough room here. So here is the second bullet. It told you that there's a lease. So you know it's an annuity. It's a present value annuity. And you're solving for the recurring payment, right? So that setup looks like the following: 300,000, 0.0426%. Compound period is 12. And just have to remember that it is a negative number right here, which is negative 420, and again over 12. And then once you're done here, this implies that your recurring payment is going to be $1,375.51. And this is the second piece to your model, right? Now the last one's relatively easy because it already told you that what's happening right there. Right here, underlining in green, you place an ad for your business for the first month for $2,000. So it says basically a one-time expense of $2,000. Notice though that it says for the first month only, right? When you're making the model now, when you're pulling everything together, and again, just this time around, I'm going to show you the model symbolically. Which is your profit function minus the recurring payment minus those $2,000, or you can just use the numbers. Numerically, right? So that would be 10x minus 1375.51 minus 2,000. Again, either of these answers are acceptable. There's no need to have both of them. But if you do, it's not gonna mark questions off or anything of that nature. Just gotta have at least one of them. Some students in the past have asked, hey, do I have to combine the 2,000 and the 1375.51? You could. However, as I mentioned before, and I also suggested, you want to keep not only the months separate, you want to keep the expenses and the profits separate as well, because if there's a change in the future or with the follow-up question, you'll be able to easily not only see it or seek it out within your model, you'll be able to change it easily, right? If everything is all combined to, you know, one big number and one other big number, then it's difficult to see what the difference was, okay? So I would say, yeah, you can absolutely, you can definitely keep the entire model set up and you can combine the numbers and everything of that nature, but I would suggest not to, because again, if you have to manipulate, it'll be easier when you can see everything, whether it's color coded like this or you just how you label it. So this is step 2 completed. So if we scroll up, right, we just finished step 1. That's good right there. So this is done. We just did this, and now we can answer these follow-up questions, right? Part A, let's just take a look at these really quick. Part A is asking you how much was made if 50,000 tickets were sold. Again, that's a calculating based question. Okay. Part B, assuming the same ticket selling scheme, how does the second month's model differ? So hopefully you notice, or as you're thinking, don't worry, we'll talk about it. You know, what's staying the same, what's different, what has a one-time effect, what has a recurring effect. Part C says you made a lot of profit from the first 2 months. Now you have a goal of $250,000 in 20 years at 3% compounded weekly. What needs to be deposited in the third months, and how does this model differ? And then part D here, now you can see, since I incorporated cost revenue profit into the model, I asked you about the break even for the third month, okay? So just think about that for a brief moment. Some of those answers you can answer off the top of your head. Some require calculation. And no matter what the case may be, what you want to realize is that you just want to recognize. Once you recognize, you can at least take a step in the right direction of how to take the approach to solve, okay? Let me just make sure I didn't lose anybody and see if there's any questions here. Yep, I got someone here. Do we assume the model stays the same from the second to the third? If it doesn't say, use the original model. Okay, so that's a great question from Olivia. What happens is that if nothing changes, say a recurring payment, leave it the same. If I don't tell you that it changes, you can also assume that it has changed. However, once there's a change made, you carry that change over. So I know I just said change 3 different times and it sounded like I said the same thing 3 times, but let me just point that out in the last example really quick. Okay, so notice how, okay, here we go. Notice how I'm gonna do some red. I know red's very glaring color, but it'll be just easier to explain that way. Notice how this is a recurring payment, and this is a variable, right? So when I moved from the first month to the second month, those recurring payments don't change. So that's why they are still the same, but this changes, right? This is the variable change right there, right? Whether I said assume that the first month follows from the second month, or whether I say assume that you don't change the first month, or whatever the case may be, right? I explicitly express that you now make revenue 10 times the number of employees instead of 5 times. That's the only thing that changes, and that is what has changed for the second month. Now, when you move to the third month right here, again, notice how that's the recurring payment, and notice how this 10 stays the same, right? There's no reason for you to revert back to the original 5x right here, which was right here, right? When you're on this third month now, there's no reason to revert back to 5x unless I explicitly tell you. So that's why it's following the same scheme where the recurring payments, they follow after. And even if the 10 was not the original model for the first month, it carried over because I would have told you if anything changes. And of course, this number right here is new. So hopefully that answers not only Olivia's question, but anyone else's for that matter. And the same thing is going to happen here too. This is our first month's model. And then the second question, the first question was first asking, so question 1, questions now. So number one here, or A, I'll just say first, it'll be easier. They told you that X is equal to 50,000. So what do? You take that first month's model, you plug in your 50,000, and you calculate. So whatever this outcome will be, this will be, is this the same number I used last time? Yeah, I think so. So this will be $4,960, $496,624.49, semicolon, positive outcome. Now, aligned with what Olivia was asking earlier, she goes, hey, do you always have to wait for me to tell you something? And the answer is no. You carry everything over, right? You now have 10x because we kept the same selling scheme of the tickets. And we have the recurring payment of the lease of the office. But then you realize, or hopefully you realize, that this 2,000 does not come because it was a one-time payment, and it was noted right here, right? You place an ad for your business for the first month for $2,000, and then that's what's leading to letter B, or the second question here. Assume the same ticket selling scheme. How does the second month's model differ? Well, you have no $2,000 expense now, right? You save $2,000. So this would be your second month's model. Okay. For the third question here, second question, first question, right? We're asking now that you made a lot of profit for the first 2 months. You now have a goal of $250,000 in 20 years at 3% compounded weekly. What needs to be deposited in the third month, and how does this model differ? So again, same thing here. I know I didn't say assume the same selling ticket scheme, but we're still going to keep the 10x, right? Nothing has been notated or explicitly stated to make you assume otherwise if anything has changed, and then there's no statement saying that we're going to revert to the first model or the original model or the first month's model, however you want to think of it, okay? So hopefully that answers your question, Olivia. For this one, when you're looking at part C here for the question, right, you have a goal of $250,000, 20 years at 3% compounded weekly, okay? And then it says what needs to be deposited in the third month, right? So what happens is that here you should realize that this is also a single deposit as well. Single or one time. Right? So this is not an annuity. Part C here is not an annuity. So the third question here, we notice that there's a compound period of 52. I'm telling you that it is not an annuity. And last but not least, that means that we're going to be using this equation again. 1 plus I raised to the n, okay? With those numbers filled out, it is, wait, did I say $250,000? What was here? Yeah, $250,000. $250,000, 1 plus 0.03%. Again, compounded weekly, and we're over how long? 20 years. Okay, so I can't do that in my head. So that's n equals 20 times CP. 52 times 20 is 1040. And I don't have this answer written out, so let me get this answer for you. 250,000 divided by 3 divided by 52 raised to the 1040. All right, so this is going to be 137,226 and 65 cents. So this is needed because now for the third month's model, we're going to have this 10x still, right? Even though I didn't say anything explicitly, you can assume that it carries over because I haven't told you as well that anything has changed. And then now you have this last expense of 137,226.65. So this is the answer I'd be looking for part C, or the third question, or question number 3, however you want to number these. And then the last question was asking about break even, right? Fourth question here. Not only is it asking for break even, but they're asking for break even specific to this model, right? So you don't have to worry about the original model or money carrying over. And that's another reason why we don't want to focus on these numbers right here, specifically this 496,000, or having to carry that over for the third month, or having to worry about that for break even, right? We want to keep them individualized, even though we know they exist. We just want to keep the months individualized because it's kind of like an Excel spreadsheet, right? You look at your monthly expenses and you look if you're in the black or in the red as they use for accounting terminology, whether you're in profit or you're at a loss or whatever the case may be. So what do we do for break even, right? Remember, we want to set the model, equal to 0. So if this entire thing is our model, right, this implies that 0 is going to now equal 10x minus 1,375.51 minus 137,226.65. And then now this is the time to combine numbers together because we're actually solving for a single number here. Okay, so you combine these two. What do you get? We get 0 equals 10x, and this becomes minus whatever this number is, 1,375.51, 137,226.65. Okay, we get 138,602.16, and then that's going to go to the other side, and then we have to divide by 10, right? So in other words, this becomes now 138,602.16 equals 10x. But if you're going to divide by 10, that means that you're going to move the decimal to the left 1, right? To divide by 10 is the same thing as moving the decimal place to the left. That's what it means. So now our x equals what? 13860.216 what? Not dollars, right? This isn't dollars because set the model equal to 0 for break even means $0, right? Those are all dollars, so it's not dollars. These are items. What items are we talking about? We're talking about tickets, right? However, we don't end it at there. We always do what? we round up, right? To next whole number. So in this case, X equals 13,861 tickets, right? You can't sell 0.216 tickets. And that's your answer there. There you go. Right, so this really digged a little bit further back in terms of the cost rendered profit, but you can see now how we're combining things together